Hello. In the session of today, we will ask ChatGPT about tables having uniqueness or not. So let's determine ChatGPT to provide us a SQL statement that we can use to discover which tables have no enforced uniqueness in them. So let's write here the question. Please tell me, please provide me a select statement in PostgreSQL to obtain all the tables in user schemas that do not have any form of enforced uniqueness. Okay, let's see. First of all, that's wrong. Uniqueness is enforced not by primary keys, not by unique constraints directly. Uniqueness is enforced by the indexes on which primary keys and unique constraints rely upon. So it is important for us to see also the indexes themselves, not only the constraints. Therefore, PG class, PG namespace, PG index, in NSP name, no unique indexes. Okay, the indexes were added here, as we can see. But the statement no primary keys or unique constraints is not quite right. The SQL statement is up to a point. It is right up to a point. So what we do here, we join PG class with the PG namespace in order to exclude PG catalog and information schema, which are not user schemas. And we eliminate here, it is anti-join that it is used here. We we keep only the tables that do not have an associated unique index. But the answer is not enough. Let us switch to dbeaver and prove this thing. Okay, I suppose now we see the dbeaver screen. I have prepared here a table which is select concurrency named. We do have a primary key constraint. We do have a unique constraint. We do have a unique index on both columns ID and value. What we get with a similar select as the one provided by ChatGPT, but without the anti-join, we do obtain here the tables that have indexes on them, all the indexes we have. So we do have this table select concurrency having a unique index, which is also a primary key. We have the index defined for the unique constraints, but it is not um, marked as such as corresponding to a unique constraint, at least if we look only at the table indexes. Okay, PG index, table PG index. We do have our single index defined without any constraint above the index, and which is also marked as unique and primary index. But we do have another table, range test MG exclusions, range test MG XCL is the index name, and the table is test range test, which is not unique, which is not primary, but which is exclusion. Now let's look at this table to see what it is about. What is that special with our new table? Our new table has a very simple definition. We do have a single column, which is defined as a numerical range embedded data type. So this is a Postgres data type, one which is available inside the Postgres engine. And we create an exclusion index using GIST index technology, and the condition put on the column range is that we don't have overlays. This is the overlay operator. So any range in this table is not overlaying another range in the same table. I mean, they don't have common values. Okay, this table is empty, so let's insert ranges 10, 11, 10 included, 11 excluded, the range 1.1 to 2.2, and the range 20.01 to 100. The second range is included with all the edges. The left edge at the third range is not included, while the right it is. So okay, let's execute this statement. 3 rows inserted. We can check. Okay, we do have these ranges. Let's try to insert again the value 10, 11, exactly as it was previously inserted. No, it is not possible, because it violates not a kind of uniqueness. It violates the overlay operator, which in our case is also a form of uniqueness. Let's also try to do this, which is only an overlay with the half of the first range. It will give the same kind of error. It doesn't matter if the range is complete or not. It matters only if they have or they don't have common values. So what we can see here, even this index, which is not declared as unique because its primary goal is not to be a unique index, ensures via the operators used and the GIST indexing technology ensures the uniqueness. So the answer provided by ChatGPT is far from being complete. Is far from being complete. It looks only at the obvious int is unique column of the table indexes. Frankly speaking, I was expecting to obtain better results than that, only looking at indexes that are declared to be unique, but also at other restrictions that have as consequence the uniqueness itself. At least a warning to be raised about that. So we may have tables that have uniqueness, but which are not enforced by a unique index. Thank you so much for looking at this new SQL and AI episode. See you next time.